Okay, we are live now, me and Eri. Today we're gonna have Victor Rentea, and he's going to talk about the Refactoring Games, 15 things to do after structuring a method with Java. Eri, French, it's up to you.
Hello. Hi. Oh my God. I was sorry. I had the YouTube at the same time and there was some like terrible echo. Oui, en français d'ailleurs. Je vais passer en français, mais évidemment la présentation sera en anglais aujourd'hui. Bonjour à tous. Sinon, euh, qu'est-ce que j'ai? Je voulais vous faire faut pas que j'oublie. Bon, première chose, on a Banque nationale du Canada qui a re-signé pour 1 an de sponsoring de commandite avec nous. Donc, nous sommes très heureux de les avoir. Ils devraient apparaître sur le site sous peu. Donc, merci de leur confiance et des belles choses qu'ils font dans le monde du Java. Euh, ensuite, j'avais un petit peu de qu'est-ce qu'il y a de neuf en Java. Euh, ce mois-ci, je vais vous parler un peu de JDK 16. JDK 16 est en train de prendre forme un tout petit peu. Pour ceux qui s'amusent, les choses intéressantes, c'est une API pour les vecteurs, donc pour être capable de faire des calculs matriciels. L'idée est évidemment d'être capable d'en arrière utiliser des cartes GPU ou les chipsets Intel qui permettent de faire ce genre de choses. Donc, pour les gens qui font ça, il y a beaucoup d'heureux qui vont avoir beaucoup de performance quand ils travaillent en Java. L'autre chose hyper intéressante, c'est que c'est officiel que Java est maintenant sur GitHub et donc sur Git. Donc, la version OpenJDK de Java est maintenant disponible et si vous voulez faire des pull requests ou bien des issues, c'est directement sur GitHub et il n'y a plus à aller sur le terrible Mercurial très lointain et compliqué à utiliser qui existait avant. Dernière chose, qu'est-ce qu'il y a comme là? Il y a plusieurs autres petites choses intéressantes. Ils sont en train de porter la version du JDK sur Alpine Linux pour qu'on puisse avoir des petites images en Docker. Donc, je trouve que c'est une excellente nouvelle et ça m'intéresse. Il y a d'autres choses comme les record de pattern matching et puis les field class qui record et pattern matching vont sortir pour vrai en 16. Les field class continuent à être en preview, mais ils continuent leur petit bonhomme de chemin. Il y a une API, ils appellent ça le French Linker API, qui est un remplacement de JNI pour avoir quelque chose d'un petit peu plus joli et plus performant, euh, qui peut aussi être intéressant. Je pense que ça fait le tout. Hein. Je regardais ma petite liste de JDK, mais donc c'est une version encore assez amusante parce que il y a plusieurs petits features qui vont nous apparaître là. Donc, je voulais vous en parler. Les deux autres choses, là, c'est là où il faut que j'aille chercher mon calendrier. Donc, si vous voulez commencer à regarder, il va y avoir, donc, je pense que DevNexus, ils ont le line-up et ils ont ouvert, évidemment, c'est un truc en ligne. Ça va être 18-19, je crois, 18-19 février. Donc, si vous voulez regarder DevNexus en ligne, pour une fois, vous n'avez pas besoin d'aller à Atlanta pour y assister. Malheureusement, cette année, je n'y présente pas. Euh, mais, euh, mais ça n'empêche que c'est une excellente conférence. Les autres conférences, il va y avoir encore Boston à Montréal, mais qui n'est pas à Montréal par la force des choses, qui va être en ligne, mais de Montréal. Ça, c'est les 14, non, les 15, 16, non, 14, 15, 15. Le 15 janvier. Ça, j'y serai, comme souvent. Et quelque part, j'essaie de ne pas me mélanger, mais je le trouve pas dans mon calendrier parce que j'ai pas dû bien m'organiser. Mais proche de ces dates-là, vous allez avoir quelque chose de tout nouveau dont je m'occupe de l'organisation. Ça s'appelle la Java Champion Conference. Et donc, c'est une conférence peuplée de Java Champions qui, en fait, que des Java Champions. On a décidé que comme pour une fois, on était en ligne, ça serait amusant d'avoir une conférence parce que c'est dur d'avoir tout le monde au même endroit généralement. Donc, vous allez avoir plusieurs conférences sur différents thèmes faites par des Java Champions. Donc, c'est autour du 15 janvier, mais j'ai pas les dates précises. Il devrait y avoir plus de publications sous peu, parce qu'on n'a pas fini de faire le planning. Voilà. C'est peut-être tout ce que j'avais pour vous. Je vais laisser Rowan présenter notre présentateur de la journée et amusez-vous bien. Merci.
Okay. Victor Rentea is a Java champion and a former lead architect at IBM and the founder of a Bucharest software craftsmanship community in which he spreads the word about simple design, refactoring, and unit tests. And I've seen some good work that he has doing. And we decided to invite him to a good talk for you guys. And Victor, come here.
I'm here. Hi everyone. I'm from the other side of the world. It's 12 in the midnight, right? It's midnight on my side. So nice to see
you.
Thank you for inviting me. Let's see how this goes. Let's see how fresh I am at midnight. Okay, so do you see my screen? I will try to go you through some of these. I'm sure if we will cover all the 15, but we will do as much as possible. Let's start with the code because that's the best way to start. So the thing is, extract method and rename are the two major refactoring that you should always be always have in your tool, but always have in your hand. And so you will extract functions very often. Let's try to extract some heavy logic. So imagine this is super heavy logic, right? Like huge, and you want to extract it from here. Let's name it, I don't know, some big function. After extracting it, what happens? You see that the order of the parameters is not the perfect one. You see, so it's D and then A, B, C, and let's imagine there is an order in this. There's a natural order, like I don't know, first name and last name. You wouldn't pass last name and then first name and then middle name, right? You want then to adjust the order of the parameters. So how you do that? The old style is like refactor and then change method signature. I don't even know where that is because I always press the keys. And D, I will move down. When you do that, so reordering parameters, it will reorder it everywhere where the function was called. So here we go, refactor, magically reordered it. Very, very powerful technique. Sometimes it's very useful to have the parameters in a certain order, incredibly useful. Then when you have a better name for that, and another trick for you here, in case you never find a good name for a function, just choose a Welsh name. Do you know this joke? It's an old joke. When you don't know what name to find, if you don't have a good name for a variable, choose a Welsh one. Can you imagine getting down at this train station? Just imagine. You will be ashamed to commit this on the Git. So that's a good one. You won't leave it like that. So it's a temporary name, of course. Until you find a smart name for this, an explanatory name. Now, let's move to the next one. So what we saw, we reorder parameters and rename a function. Easy stuff. Now, let's see what happens if you extract this. It's very, very evil. If you look at it, what the heck is here? What's this? It's a switch. Now, what's that? Let's extract it to get better vision. Let's see what we get. Base cost equal A of day and base cost. What the heck is this?
Victor,
why is it? Yes.
There's one thing. There's one guy just telling us to zoom a little bit.
Zoom, sure. Thank you. Perfect. That's it. Okay, good, nice. So we have this problem now. We have base cost equals 0, and then base cost equals, now what the heck? This is 0. It's always 0, right? So at the moment you realize that, you have two options. You can either go ahead and do the Tarzan style. Let's see, we need to delete this and then define a variable. You know, you feel how hard this is. Or you can do the best refactorings of all, Ctrl-Z. I have this belief that if you didn't undo 10 times a day, then that's a bad day. If you didn't undo 10 times in one day, that was a bad day. You didn't learn anything that day. So let's undo. And let's see how we can fix this. But this variable here is defined around here. And then there is an if. And on the else you throw. You see, this switch is so deep in because there is an else branch. A simple trick here is to invert the if condition and throw early, right? Which will make the else be able to unwrap, be destroyed. You don't need the else, really, right? So Alt-Enter, unwrap. Oh, good. Now base cost from here is used only here. What we can do, I call it the C style of, you remember C? when we started like that, it was beautiful. We defined all the variables at the beginning of the functions. Ugly. In Java, of course, we should move them as closer as possible to their usages. This is very powerful refactoring. It will move it to the minimum enclosing scope, which doesn't introduce bugs. So it won't put it, I don't know, here or other places, it is still correct. Okay. Now, if we have this code like that and we extract the switch again, this is with what we started from, we will see the same 0 coming in here, which is nonsense. So undo again, from Zoro. So undo again, and let's see what happens. I want to take not only this switch, because I select this block. Base cost, since it's defined before the block, needs to go as a parameter inside. So what I will do is very simple. I will take the variable with me, and I will make it the switch. The switch. Good. This is good. I don't need any parameters anymore, right? So by extending the scope of the selection, I can reduce the number of parameters by taking other variables with me. What I will get here is a switch in a single method. Now, I have this question for people typically. I mean, do you love switches? If I ask people this question, almost always I will hear like, nah, not quite. Maybe sometimes, right? And for that purpose, I want to provide a set of rules. These are my rules of a hygienic switch. When is a switch beautiful? The switch is beautiful when it's the only instruction in a method. What do you mean by that? I mean, there's nothing above it, nothing below it. We kind of followed the rule, almost, not quite, right? Because base cost is defined there. Can we move the return closer to computation? Ooh, we can. Nice. So what this one did? It every time these cases assigned the variable which was done return, it directly returned at that position. Very good. This destroyed the variable up above, and here it returned 0. What the heck, 0? Is it normal to return 0 for this case? What am I doing here? Computing price. Oh my god. So get price per day, or compute price for day. Okay. Now it's not very usual to have a 0 price, right? And if you look closer, you will find something very interesting. Saturday, Sunday, Friday. There are only 6 cases, but a day, the week has 7 days. So it's missing a case. Let's see if it. Case, and there you go. Case Wednesday. This is missing. Okay, and basically on this one it should return 0. It's like, what the heck, right? And I will put a to do here. Possible bug. Now, what the heck is this? Right? Now, this trick, however, will allow me, I hope, to remove the return. But in Java up to 15, it won't, because you need a default branch. Now, this leads me to the second rule. Every switch has a default branch. Now, how you do this in IntelliJ? Alt-Enter and insert default branch. It's automatically there for you, just that you know where to search for it. Okay. Now, this is very good. And the third rule is the dramatic one, however, by the way. Why do we put this default throw? This is called GDD, in case you never heard of this technique. It's the most widespread software development methodology in the world. Let me show you. GDD software development methodology. It comes from Jesus-driven development. We hope. We put that default branch in there because we hope that some brilliant tester will actually test with something which was not. Why are we putting this default really here? Will a new day appear in the enum? Very unlikely. But if this were an enum that we could add values to, then adding a new value might leave a case which wasn't covered, just like this one was. Okay, and we put this default here just in the hope that someone will actually use that value sometimes. Okay, and then it will get the exception. So we hope that we get the exception later on. Now, you've heard. I didn't recall the name. In French, they were talking about the Java 15. Let's just for fun. Let's try to advance this to Java 15. Just for a second. I'm not sure if I can do it that fast. Let's see. 15. Let's see what will happen in 15. Okay. I know that you aren't probably writing right now, putting the production on 15. I hope. But let's see what happens if you do. Well, if you switch to 15, first of all, the IntelliJ will tell you that you can replace this with an enhanced switch. What the heck is that? An enhanced switch can directly return. Whoa, return switch. Hooray. Finally, we have this in Java. Hooray. But what's interesting here is that the default is not necessary. What do you mean it's not necessary? And IntelliJ highlights it and tells you can delete it. But wait, I used to put the default there because I wanted to catch the cases that weren't covered. What if a case is missing? There's the most beautiful part of the switch, of the enhanced switch. This does not compile. Yes, finally. The compiler can figure out. You are switching on an enum. How many values are the enum? 7. How many cases do you have? 6. You have a problem. So the compiler can now check that you've covered all the enum values. The conditions are that you return the switch and that you switch on an enum. If you do both of them, the compiler will check. You won't even be able to compile this unless you cover all the branches, which is brilliant. This is a brilliant addition to the language. Okay, if you think of it in more detail, it will be obvious, right? You need to return something. What would Java be able to return if the day is Wednesday? It's like an if that an if that doesn't return on all branches. It's like, what should I return? So very interesting. This is a very good addition to the language, and it goes very close to my rule actually, because I would say that the third rule is that you have one line per case. If you do a case and then you should directly return, or you should call a function and break if your function doesn't return anything. These are very similar to what Java 15 gives us. If you look in the code here, it's one-liner. You can call a method here. That method will return something, and your switch will return that thing also. Good. So this was I will call it this hygienic switch. Okay. Cool. Now, it also you realize we identified that we were able to create this cool clean switch only after extracting and with extracting methods. Very cool. Now let's move for the next one. Let's suppose you have these lines of code. Okay, allocate ticket 1, allocate ticket 2. And then you need to implement at some point allocating a variable number of tickets. Now, imagine this is not just one line, but this is complex logic here. But these two chunks of logic are very similar with one single difference. This one takes 1, and this one takes 2. How can we do it in such a way that we will reuse? Now, I know this is a bit oversimplified example, but look what I will do. I will split the one here. Actually, I could even extract it as a variable. IntelliJ is able to extract from a string. This is like, what? Look, I select this variable. Okay, and this is like n. But I don't want to make it a string. Let's make it an int. Okay, n equals 2. Good. Now, I extracted the variable before the chunk of logic that I want to extract. I will now extract this part. Look careful. This blue block here will need as a parameter the variable defined above. So I will expect to have a parameter to the method. Great. And I will say allocate ticket. Good. This method allocate ticket and here I will now I will inline the n back. So this is the sequence of 3 steps: extract a variable, extract a method, inline back the variable in the method call, like that. Okay. The variable. There you go. And this will allow me to reuse it in more places, like here. You see? So this sequence of steps is very, very. Let me put this. I have a refactoring. I will do something for a different presentation. Really, it's called. Let's say this sequence of steps. I've done it a lot of time, many times, because it's very useful. Because your IntelliJ, your IDE, no matter what IDE you are using, they will all get that. So what's the trick here? You parameterize a function. How is that? Well, first of all, you extract a variable like we did, n, okay, to make the syntax identical. Let's force this even more. Let's imagine the two bits of similar code like this was in a different function, in a different place, like here. Okay, let's take it here. Okay, and what you will do here, you will extract this also as a variable, n. Okay, let's name it n again, and I will put it 1. Now, if what you had above below here, it's similar syntax. I mean, you see, if you look closer, it's the same syntax here and here. I will need to extract this variable again here. There you go. Now, this not string in, please. It's the same syntax, okay? While at the moment that it's the same syntax, the spaces don't matter, formatting don't matter. The IntelliJ will look at the abstract syntax tree, okay? And we will get that there is duplicated code fragment. So allocate ticket now. It will extract from both places automatically and refactor. Okay, here, replace. After which you will inline the variables back in the method call. These sequence of 3 steps are very useful to master. So first, extract the variables to make the syntax identical between the similarly looking code until the IDE detects the duplicates. When you try to extract one of them, it will report that there are duplicated code fragments. That's you winning, right? That's because in complex situations there might be slightly different pieces of code that you might not get all the differences from. Right? Imagine 5 or 10 lines of code. It's tricky to check every. So what you will do, you will extract all the variables above until you match the same syntax. At which point you can be sure that your IntelliJ or your Eclipse or your Visual Code will extract the correct code. Okay. After which you will inline the variables in the method calls, like we did here. And okay, these 3 steps. You can use this technique even if the similarly looking pieces of code are far away. But then the first step to do is to move all the similarly looking code to the same file. This technique, I mean, matching duplicated code will only work in the same file. Okay, so by moving methods from one file, from one class to a single class or everyone, you will then be able to do this technique to make sure that the syntax is identical. You don't introduce bugs. Okay, so basically parameterize some, extract variables, extract function, and then inline the variables back in the method invocation. Super powerful technique in large code bases. Nice. Now, let's see the next one. Here we go. It goes like cancel order. What the heck is this? Cancel order takes an order. No, my God, what's this? Oh my God. Ah! And you start screaming because it's the if spanning 3 lines. Who the heck does that? And if on 3 lines, my God. And then there's the beautiful thing that, right? Imagine you are at midnight, like I am today. Right now, at this moment, I'm not entirely sure if and has a bigger priority than or, right? And you have this mystery ongoing. Oh my God, will this execute first or will this execute first? In case you're missing parentheses, you kind of are lost, right? Unless you know the trick in IntelliJ or Eclipse, you can select growing blocks. Right? Look what I'm doing, Ctrl-W. I'm not sure if you're on Mac, it's Command-W, I think. It's selecting larger and larger blocks, and it becomes obvious right now that the next block is basically this is higher priority than or. I knew that, but in case I didn't, this is a very simple technique but anyway, doing this kind of work when you have bugs and deadlines and oh my God, right? You want to simplify these Boolean conditions here. How would you do that? Well, let's see. Order get status equals order status new. I could make first a variable like is new order. Okay. How is this? This is payment failed. Let's make a variable first. Payment failed. Payment failed. Or by the way, was. Oh my God, the guts he has. You mean I'm allowed to put the verb on the past tense? Oh no, come on, really? Okay. Now this thing actually smells like highly reusable bit of logic. So why not putting it in a method named the same? Was payment failed. Perfect. Refactor and then keep. What will happen now? Was payment failed is here in this class, but guess what? I want to put it on the order itself because I find it's very convenient to have this in many places in my application. What I can do then, so if you look at this very closer, you will see that this function really only works with the data that comes in the parameter. It doesn't have anything to do with the class which contains this method. So this is a sign. This is an occurrence of the feature envy code smell, because you are working with the data of another class. Okay. So if you ever feel that you have business logic which might fit better in the order itself, move it. F6, master. Do you want to move it in the order? Like when I first saw this dialogue, I was like, what? Why are you proposing order? Because master, I saw that you take order as a parameter. My God. So this will move this method inside the order. What the heck? How is that? Oh my God. You would work on that at least 2 or 3 minutes. Like manually backspacing and what? It did it automatically for you. There you go. You are in the order, was payment failed. Do not call your own getters. It's a sign of narcissism. Just access your field. Come on. Okay. Good. Was payment failed. Excellent. Now, how about this one? The same. Make method. Is new. Move. F6. Make public. Out. And oh, it was private, so I need them to. Oh, I missed something. Let's see. Is new. What am I missing? Ctrl-Z. The most powerful force in the universe. Okay, let's see what I'm doing wrong. Let's make it public first. Public Boolean order. Okay, F6 order. Excellent. Public refactor. Is new is already defined. Oh, I was stupid. There is already an is new in the order. It was already there. Is new. Is new. Thank you. Good. Now I've moved the method in other classes. Very good. This moment, this variable doesn't worth to exist. I can inline this variable back and inline this variable back. But how about this one? What's this? Well, order get order lines non-match is special offer. Okay, I can do that. It would be called has no special offers on the order level. And then guess what? Move out. Public. You're out. Has no special. I think the function was already there for some reason. I'm not entirely sure why, but let's remove that. Okay. So has no special offers. That's it. So basically, I've moved the bit of logic inside the very entity, which allows me to have it like that. Oh, and guess what? I can extract this completely and make it is cancelable, for example, in the order, and move it in the order. Public out. Okay. So I can push logic out of my core business logic into the data object that I work with. I know this is not a very traditional enterprise style development in which you should separate the business from the data, the business logic from the data. I've heard that many times. Oh, the business logic should not be in the same place with the data. I mean, like, what? If you can put little bits of logic inside your data objects and such your entities, do it. It will clear up the logic in the middle of your application. Right. So never hesitate to push little bits of business logic in the data object, even entities, in value objects that you have. Okay. Let's move for the next one. So I have this intervals intersect. Oh, what's this? This is a method that was extracted from here. Okay, so the extraction already happened, and after the extraction, you see that you have 4 parameters, and you wonder, now what the heck? Why do I have 4 parameters? It's too much. There was this old rule: more than 3 parameters is smelly, right? We are pretending here. Last week, I did a training with a group in PHP. They had 25 parameters in a method. I was like, what the heck? 25 parameters? But yeah, 3 is too much. So this I could invent something, this intervals intersect. What does it mean, like, right? You have a start and an end of an interval and the start of the and the end of another interval. Oh, wait a second. You know what I can do here? I can introduce I can wrap these two in another class named interval. Just make sure. Let's delete that. It shouldn't be there. Thank you. Now, let's create this new class interval. How would you create it? Okay, we all know to create a class, but you might not know that you could introduce a parameter object and create the new class right from here. Interval. Only the 2 first parameters will go in this new class interval that I will create just now. Refactor. What happens? Without breaking compilation a single second, you see here that a new interval was instantiated and passed to the method automatically, right? So it changed the method invocation also to instantiate the new class. I mean, like, what? Really? And there's more than that. You can use the same interval for these. It's a variation, but it goes the same way. Introduce parameter object, and these 2 arguments, int, should use the existing interval class. Interval from my 15. Wrong one. My God, what's that? Interval, please. My own. Thank you. Okay. So pay very much attention to the order of the parameters to match the constructor arguments. Because, by the way, the interval that was automatically created has private final fields and constructor with start end, right? When you replace the arguments here, pay attention to have the arguments in the correct order. Good. Now, this is, let's adjust a bit the names here. So you get the point. I'm creating a new class because the method signature of the method was too heavy, had too many arguments, right? And I'm creating this little value object, which is very nice because, there you go. Here. So we have two intervals. But then it's fair to ask yourselves, if we intersect two intervals, wouldn't it be more object-oriented to have the logic in the interval themselves? That's interesting. How would you do that? Well, let's try to move the method. Where could you move it? In the interval itself. Again, IntelliJ figures out that the parameter, it can become the home of this method, and it allows you to refactor and move it there. There you go. Intervals intersect. But by the way, since we are in the interval, look how this reads. And you get the point, right? The IntelliJ automatically replaced, and look, the code compiled. I did not break compilation a single second today. I mean, almost never. Intervals intersect. There you go. And then dot. Now, what's the trick here is that it sounds a bit strange. New interval dot intervals intersect. It will be more readable. Intersects. Okay? Now, this intersects, which should take not interval one, but other. Okay, and no more narcissism for you here, please. Come on, get real and call your own getter. What are you doing? The getters don't really exist at runtime anyway. They are in line after just 1,000 method calls, so they don't exist really. So there you go, interval intersects. Very good. But now, intervals are able to intersect themselves, which is interesting. It's more rich. It's a more rich object model. It's a more rich entity model. Now, there is more than that. But I'm not sure it has to do with extracting methods. No, so I would like to skip that for a second. Let's see the next one, because the next one is a bit more dramatic. Every now and then, let's also check the things that we saw already, right? We saw renaming the methods, of course. We saw inlining the methods. Didn't saw inline the method? Let's do it. How do you inline a method? If you inline this method, you will destroy the method and move the body in the place where it is called. Inline the method. There you go. Right. A very powerful technique when the method is called in remote places from other classes. Right. It's a very, very powerful technique. That. Okay. What did we do? So reorder parameters. Yes. We removed parameters by extracting more. When we included the around here the base price or something like that, we included an integer at the beginning here. Right. We distilled switch expressions to clean switch. Okay, and then we also played a bit with Java 15. Early return errors we didn't, but yeah, we do that also here when we flipped the if. We flipped the if and we threw exception early. This is early return errors. Then we add parameters for reuse. Yes, we did that at this position. We introduced more parameters to this method in order to be able to call it from other places. By the way, there is another technique that you can use, and I want to show that to you, but I don't have an example prepared for that. Let's make up one. So we have some complex code, okay, which is repeated complex code, okay, and this is in an if something. Okay, and then something needs to be a Boolean. Thank you. And at this particular line, let's suppose that this method appears here also. Complex stuff, and it's different. This is complex code. This is complex stuff. I don't really care to see what's there, but what I mean here is the following: if you extract this one, right? Is it right? Yeah, maybe. Let's see what happens. Like this. Where are you? AAA or something. There is a trick that you can use here. It's called introduce parameter. If you have some complex logic inside, you can take some of that logic and introduce a parameter. Look, again, before was like this, and afterwards introduce parameter, very powerful. So imagine you have 20 lines of code and some argument inside you want to parameterize. By introduce parameter, the value that was literally there will be pushed to your caller so that you can call the same method by passing stuff here, which was the different thing between the two things. It's a bit of a twist because I've started by extracting the real method and then I've parameterized it. And when you parameterize it, you'll actually push this some constant expression from within. Let's try again. Let's extract this again. You will push a complex expression from within to your caller. You see? Very interesting technique to make the function more applicable to other situations. But again, mind that you don't exceed 3 parameters because it starts to be fishy afterwards. Okay, so yes, let's see this one. This one is a bit more complex example because imagine that do you know? Have you ever seen a query which starts with 1 equal 1? I mean, is it? I believe every software engineer in their career will hit such a query at some point. Why do we do that? We've done it since 30 years ago. Why do we do this? Because we then want to append different criteria to the query, like we do here, right? If the name is not null, then we will add something to the query and put some parameter in a map. And if you will have more of such situations. If name is not null, if other criteria are not null, and so on. Now, imagine there are a lot of such chunks of code. If there are many, let's see what happens if you want to extract these. If you want to extract these like this, you will find the following strange thing. You will find that the query string enters the method and then it exits the method back. And besides that, so this is very strange. If you see it, it's like, what the heck happens? And there is more than that. There is this params map that you pass in the function, and inside the function, you change the parameters. This is very, very weird. Adding stuff to a parameter, changing the state of a parameter, is something that might surprise your callers. People might not expect that. So to avoid both this case and this case, I mean, what will be ideal? Ideally, the function should return what it produces. What does it produce? It produces an entry in a map, but it also produces some string to add to the query. So it actually literally produces two things. Now, how can you extract a method which produces two things? That's the question here. A method in Java can return only a single value. And it worked, but it worked with two problems: that we are returning what we're getting and that we are changing the parameters here. Strange. This is very strange. I know you can get rid of this. If you look closer, you can get rid of that really by putting a plus here and removing the parameter from here, right? And then just returning, right? It's a risky change, but you really, if you do that, you don't really need here anything. Just put like that. If you look very close at this one, this is, I'll leave it a few seconds. It's the same thing because I'm concatenating from the outside, but I'm still left with this. I'm still left with changing the parameter map. So in other words, there is no clean design for this. It's strange. So if you encounter situations when a method has to return two things at the same time, you have basically two options. You can either, let's imagine, you can either create here like a structure that will contain the string and the entry, but this is like, what? Why would you do that? Or okay, like just return stuff, don't change stuff, only return, okay? Or there is another idea here. You could transform this large method into what's called a method object. Now, this is a bit strange. When you first see it, it's like, what? Let's build it together. It's like query, search query builder. Let's try search query builder. Now, or let's name it search query method. It's even more shocking. It's a method, but it's a class. What the heck? So how do you build one? First of all, I would like to inline this back for a second. Okay. What's this? Yuck, ugly. But I can work around it. And then bye-bye and bye-bye. That's it. Now, in this search query method, you will create a public, let's name it void execute. Now, in this execute, you will pour all this code. Good. Now, what's next? Well, I still need to get back here the query and the params. Where will I get them from? Well, the params and the query will both become fields in this new class. Fields? What? But I thought fields are bad. And they are bad indeed. Fields burden your mind. Fields, you have to take care of them and see who changed them and when they change them. And indeed, but what you gain is that you can then extract this part. Oh, name. Where does the name come from? The name was the input in this method, in the former method. So an input will be passed as a constructor to this class. So string name to the constructor. Good. Now, I will instantiate the class here, new search query method, passing the name as a parameter. Okay, good. Make this a method, although it's an object. Okay, and then this is the most hardcore refactor, in my opinion, ever. You will call the execute, right? And then you will, inside the execute, you will fill these fields, if I can say that. I mean, the method, let's make the getters for it. Get name, get params, good. And get query, good. Now, method dot get params, these are the params, and method dot get query. This is the query. And we were able to return basically two things at once from the method. But the design was dramatically changed because now we have a new object, not a method. When extracting a method gives you headaches because you have to return many things back, what you can do is to create a class. Now, this is suitable for methods larger than 1 or 200 of lines. The legacy code type of methods that you can't possibly extract anything from, because they might change 2 or 3 variables, or they might return too many things. When this happens to you, you can extract a full class from that method. It becomes a class. And from this little execute method, you can extract then all the pieces that you like. Imagine there were 2 things, right? You can extract it as a method, right? Add name criteria. You can make it a method because you can change the fields freely. You are in this instance. It's in a sense, it's very powerful because it allows you to share this data for the duration of the execution of this of all these methods. But its weakness, it's exactly the same, because you need to take care who changed the params or the query along the way. Because there are fields which survive a lot of time and give you headaches because you have to trace who and when changed them. So it's a stateful design. Thus, it's bad, but it's better than a method of 200 lines. Okay, it's a technique which is both powerful and ugly, but it's a step forward for sure. The end goal would be not to have shared state for the duration of the method execution, but to maybe invent something new, maybe create those objects that I told you with 2 results in them. Okay, so this is called extract method object. Okay, or extract command. If you look in the Refactoring 2nd edition from Martin Fowler, you will find it as extract command. Replace method with command. That's the term. Now, there is more. Let's see the next one. Yes, so extract pure functions. What do I mean here? Well, how to put this? Yeah, this get all users here. If you look at it, what does it do? First of all, it gets from repository. Okay, then you will see here stuff. For example, this conversion. You would like to extract this conversion out. Let's try to extract this. So conversion. If you do this, you will find something strange. You will find that you take the list of the user DTOs as a parameter so that you can add to it, which is what are you doing? Why are you doing this? Right? Well, these are called side effects, by the way. When you have a method which changes the state of one of the parameters, it's called side effects, and it's bad. Don't believe that it's bad, but let's see what happens if you avoid doing that. Let's go back a bit and let's extract this part and let's name it convert. Wait, my God, what's that? Convert, please. Good. Now, if your function just produces data based on the input data, so if your function just produces data based on the input data, you will have a series of good surprises. First of all, is that you can destroy this variable and directly put convert here. After which, even IntelliJ will figure out that you can replace this with a collect. There you go, right? Stream, convert, collect. Very easy. You can do this only if you are working, only if you favor pure functions. The pure functions work very nicely with stream because what you will do, you will just compute data, and these work perfectly with streams. So when you extract functions, always try to extract pure functions. I'm preparing a talk 2 weeks from now about pure functions and immutable objects at JLove conference. If you want, hunt me down there also, and I will tell you more about pure functions and immutable objects. But for this exercise, I think it's enough for now. Let's see the next one. Yes. You have a Boolean here. No, I have a typo, right? It's not Boolean, but Boolean. Let's see if I can. no. The thing is, it's a function which has a Boolean based on which it will run or not additional logic in the middle of the function, right? Now, how would you handle this one? Well, let's see. Let's see a technique. Let's see. Where are you? Oh, this is called around here. There you go. Now, true, false. A Boolean parameter into a method will mean that method does more than one thing, because obviously it does one for the true and one for the false. How can you remove it? You all know how to delete the parameter and then fix the compilation, but I don't want to do big bangs around here. I want to take small safe steps. And the safe step goes like this. It starts in a surprising way. Duplicate. My God, what do you mean duplicate? Yes, humongous method for the default one, and humongous method for my special case. That's the one which happened for the true. Now, what happens next is that you will need to replace all the places in which this method is called with a true, which calls to this method that also takes true. How would you do that? Let's see. First, let's find the invocations of this method. There you go. And then what we'll do, we will hunt every place where is true, and we'll replace to my special case here, my special case here, my special case here, and I think there is a test. Oh my God, there is a test. Incredible. My special case here. Now, if you've done it correctly, IntelliJ didn't suggest. No. Come on. If you have the nope. At this point, after you've seen that the method is called, so basically you double check that this first method is only called with false, then you know that this is false. This method argument is no longer needed. Delete from everywhere. The false never happens. Bye-bye. And this one, you know it's true. You double check. True. What you do next, you delete the Boolean, and you get two methods. Now, the bad news is that you have to duplicate code. But what you need to do, however, is to extract the parts that you've, if this is a lot of code here, make methods out of that. Okay? Like initial logic. Make methods before you extract or after you extract, like that. Okay? Here, initial logic. Very good. Okay, so what I mean here is that if instead of a Boolean argument, you always need to duplicate functions. Okay, but the trick is how to reduce the duplication when you do that. Okay, a different than null, then return. Otherwise, Leave that. Okay, and the last one. Yes. Now imagine you have this ifs on the user country. Now you are very close to a switch, so this is convertible to a switch, but for some reason, because there is so much logic here, you want to extract this one out first. Let's make a method here. Let's name it compute. What's this? Commission. Compute US commission, something like that. Good. And this again, because this is a lot of logic. Compute China commission. There you go. And here is compute UK commission. Compute UK commission. Oh my god, how many letters? And refactor. Good. Now you may wonder what is this. I keep skipping this, but I want to explain it to you, and this will be one of the last things I'll show you. Oops. Where is my? Can you still? Yeah, it's minimized for some reason. Good. Now, what this dialog is suggesting you is that look, it will suggest to add more parameters to replace more logic. Nah, it's too ugly. No, let's skip that. I won't show you that because it's just so strange. I want to keep simple. So these things here now, imagine these are very large. What you can do instead of the switch is to define a strategy pattern here. What do I mean by that? You can make an interface with this signature. So let's try to first of all to move these in separate classes because they are so big. When they are so big and there are alternative bits of logic, let's see how this feels. US US taxes, good. And where are the US? It was the US. That's it. Move it here. I will delete just keep imagining this is a lot of code. There's a lot of code there. Then the class, this is China taxes. Good. And I'll move this inside. Good. Okay, and this is the UK taxes. That's UK taxes. Now, what's next? Well, you need to be able to, since they have, let's first call them, to be honest. So new US taxes, good, dot, new China taxes, dot, compute US. Why isn't it working? It's private in a second. And new UK taxes, good. Now, all this private needs to turn into public. Now, if you do this, you will see a little duplication here. You are in the UK taxes anyway. You are in the China taxes anyway. And you are in the US taxes anyway. So by doing this, you are actually, you will have these methods with the same names. At which point, you can actually introduce an interface. You get where I'm going, right? You will make an interface like taxes, and you will put this method inside this interface, and you will implement these. I can work it. Yes, implement taxes. Now, what would you do next? You will need to do basically to first identify which one do you want to use, and then call the method in there polymorphically. Let's do this. So I will just need here all these method calls. Really, I will take it out from there. Put a semicolon. It's here. three of them. Okay. And now instead of returning, I want to do taxes equal. I want a variable. And on these taxes, I will code compute commission and return it. Now I need a variable here, but this variable needs to be a type which can be assigned to either of these. And at the end, I will just return this, but I'm throwing. I should be throwing in the else branch. There you go. Now, if you do this, you are, basically this is a polymorphic method invocation that based on the actual type, you will get to any of the subclasses. So what you get above here, if you twist it as a switch, oh, we are in Java 15 and IntelliJ was smart enough to do this. But still, I want my rules here. And I will extract this as get taxes for country. There you go. You see, my rules I still want to keep. Nothing before, nothing after, and if there were more than one line here, extract them as methods. Good. So this is like a factory method, if you like. Get taxes for country, and then on those taxes, I will polymorphically call the compute commission. So my point was that extracting methods from cases from a switch might result into a lot of logic. If there is a lot of logic, I mean 5-10 lines of code, there might maybe 20. You might want to think of a strategy design pattern like this, at which moment you will need somehow to decide which strategy you use for every concrete situation. Okay, so this was the trick of which strategies. Let's see what we've covered. Some of them we didn't. Let's see what we did. So we spawned value objects to host extracted logic. Where did we do that? We did that with the interval class. Remember, we created an interval class from the parameters of an object, from the parameters to a method. We didn't extract static Gaussian functions, but you all know how to do that. Encapsulate conditionals, we did that, where it was order.has special offers. For example, right? We moved method to object, right? With move, we did that a lot of time, right? Including interval intersect. Very useful to disseminate the logic in your data objects. Clears up the mind in the central part of your application. Add parameters for reuse. Yeah, we did that with parameterizing functions, and that other technique that I showed you, which extracts a variable, extract a method, and inline back in the method invocation. We fought with Booleans by having a copy of the method. We didn't do that. Wrap code to safely add more method. Extract methodology for heavy logic. Yes, we did with query and with that query stuff, right? When we were accumulating both the query itself and the parameters to the query. And extract pure functions, when we saw that worked nicely with Java 8, with Stream, right? And we also did strategy pattern, okay, for big cases, right? So we extract the case in a method, and the next thing you say, okay, it's two of a big method, let's make it a class, okay? And you get the strategy pattern. So they all start with extract method. That's what I find most fascinating. They all start with extracting a method, after which you get ideas. Okay. Yeah, util classes, don't do it. Please don't do it. Rename an extract method. You should always be about to do that. You should have a reflex. Extracting a rename method should be your second nature. You should know how to do that at any moment. Now, if when you extract a method, you draw a variable inside, then you don't need to take the variable as a parameter, right? So putting it inside, it will end into less parameters. Now, on the other hand, taking some expression from here and extracting it as a variable before the selection that you do, then this will allow you to parameterize methods more and to clearly control the parameters which need to be taken by that function that you extract. And after you extract these expressions and you extract the method, I showed you how you inline back the variable. The most powerful forces in the universe, Ctrl-Z. And then there is revert, and then is love, my friend. Love for your reader, to care for the poor soul who will read your code. What we had was a private method with intersects intervals. Then we ended up putting it in the interval itself, dot intersects. Right? We fixed the so-called feature envy. That's the code smell. Feature envy, when a function envies another object for the state that one contains. Okay, and we also did the extract method object. When you want to refactor a God method, like 500 lines of code, you make it a class. Okay, you make the method, you turn it into a class, and we kind of explained it in the code. Okay, pure functions, we should return the same results for the same inputs, and they should not change any state of the system. Okay, so in simple terms, prefer returning over changing. Okay, prefer returning over changing every time you can. Well, that was about it for what I wanted to show you. I didn't introduce myself, but you told them about me. Yeah, it's too late to introduce me now. Yeah, I have a website. If you want to learn more about me, I have a website and a playlist of YouTube talks. Look, if you have questions regarding what I showed you, maybe some doubts, maybe some challenges, maybe some. Not sure if I can read directly your comments or not, but if you have any, please feel free.
Okay, let me see if they have.
I don't think you agreed with everything. Come on. Yes, tell me.
I think the Henry has some question. Henry?
Please.
Do I? No. No, and I agreed with most, I would
Most,
say.
yes. Okay, but
Well, I don't think I will give a but. I think there's a bunch of refactoring to create Sprout classes out of methods that you did manually, but there's
yes, there is one.
tricks.
Extract delegate, I think it's called, and there is also extract method object, but the result is not what I wanted. Yes, so do be aware that there is a technique. Let's see if I can do it here. Extract, replace method with method object.
Yeah,
that's the one. But I would like to have better control on what. Yeah, you could try this one, but it's strange. It does invoke, which returns this back, or no, returns the results, but otherwise, to me, it's too much. I would like to do it manually. If this one, yes, but yeah, there is, and there is another one, interesting one, which I'm exploring these days. It's refactor and. Where is it? It was now move it to extract delegate or something like that. Extract delegate is not here now. I'm not sure why. Yeah, that's one thing. Good. Anything else that?
but there was I'll go through the questions. There was a question about do you think getters and setters are breaking encapsulations?
Of course, there's not encapsulation. There's just object assembly language with focusing on this word. Object assembly language. That's not encapsulation. Encapsulation is a different thing. It's exposing methods. This is not encapsulation. Private fields and getters, etc. This is not your object-oriented programming teacher lied to you. I'm sorry to tell you that, but he or she lied to you. This is not encapsulation. This is no different than public fields.
Which means, what do you think of records and all these new
with returns?
Records, the new class type that's coming.
Records. Yes, but records are immutables. These are not supposed to be object. These are just.
So you like getters then?
Well, getters I like more than setters. But the thing with records is that too often we just need to move data from here to there. Especially if you are more into the functional programming style, then you will have to work with a lot of structures if you want to work with FP. So records are there for that exact reason, to make it easier for you to. But again, records are not objects, because a decent object should encapsulate the state changing actions, should expose behavior, not state. So yeah, records are not encapsulated. No.
Yeah, it's like the payment-driven design naming. So you have entities, you have value types, and you have services.
That would be the value types, if you like.
Yes.
Although even a value type might want to hide something. There's an interesting discussion here, because the interval might not need to expose start and end. And by the way, I can delete them now. You see? But if this were a record, then the getters were there for me anyway, right? If this were a record, then I couldn't hide anything. It's there, everything, right? It actually could even work, I think. Yeah, I think it's enough like that. I'm done. Record. And
yes.
This actually works, so it's the same thing. But I will have the getters and setters. Then the getters generate for me. Yeah.
Which is, I'm not convinced by records yet. I don't know. There was another question about do you prefer Kotlin or Java?
Kotlin or Java? Well, I prefer Scala. No, Kotlin is better than Java, but I will stick with Lombok, if I can say that. And
records are supposed to remove the need.
The trick with no, not this one, but here. Well, with Lombok, you see, many people hate Java. I don't want to say that, but Java talks too much, right? And when you get tired of it, you generally face a decision. You become a scientist, you become a hacker, or you start cheating Java with Lombok. And I'm sorry to say that, but 90% of my of the companies that I go to dozens of companies, right? Oh, they all use Lombok. I mean, maybe 10% they don't. None of them, one of them uses Kotlin. But at least in my part of the world, Kotlin is still in infancy. It's not yet fully. I mean, maybe it's we are on the different sides of the world, you know. So Kotlin is super cool with the null, and I have a client which says that it is migrating a legacy application to Kotlin because they want to get rid of null pointer exceptions. I was like, what? Because Kotlin has handled nulls elegant. I mean, incredibly. Yeah. So Kotlin is cool, but the vast majority of projects, unfortunately, are still and will still be in Java. Yeah.
Yep. So
I have a question for you.
Yes, please.
What is the books that you indicate for refactoring? The guys that wants to learn about refactoring.
Sure. 3 books. Yeah, this is my main topic that I teach, and see, I'm prepared for this question. You have to read at least the first half of this book. It's old. The author did stupid things at some point, but this book is very valuable. The first half of it you have to know. Okay, some will say this is a cargo code. I don't care. You read the first half and understand it. Then read the code smells chapter, and I will show you how this feels. It's amazing. Any kind of project you have, even if you don't like refactor, if you don't know how to refactor, read the 3rd chapter. It's called Bad Smells in Code. And look what you do. You look for the things that you find in your code too. Mysterious name, duplicated code, long function. Let's suppose you have a problem with temporary field. It's a bit of a subtle temporary field. Okay, how could you fix that? And there are links pointing you to the different refactorings, to all the possible refactorings you can. So start from the pain that you have. Start from the issues of your code base and move and dig further based on chapter 3. Okay. And if you are a rookie, completely rookie, read this book. It's for beginners. You have ugly code, beautiful code, explaining on the bottom what changed and why. And there is a 4th book. If you want to practice these exercises, there is a 4th amazing book. I love that book. But where is it? It's in the clean code presentation. It's called wait. It's called Inline Back Coding Dojo Handbook. Hope I have it here. Yeah, that's it. Very good book for exercises. But there is also catalog on the Google catalog. This one. Go in this location and you will find a lot of exercises to practice refactoring. Yeah. That's how you prepare for clean code.
You're not recommending my personal favorite one.
Yeah, which one?
The working effectively with legacy code.
Boy, it's too old.
No, it's still good.
I know the themes chapter is amazing, but the problem with it is that it was written in the times before mocks appeared, and there is a series of techniques which are nonsense today. This guy is still writing for the 2nd edition. We are all waiting for that, but it's a very good book if you have methods for 500 lines, if you have classes of 10,000 lines, you have to read this. It's indeed very good book. But for a greenfield project, is overkill, right? So if it's a new project,
yeah, of course, yes, of course. And yes, it's before lambdas, before a lot of things. So there's a lot of things that you should not do anymore.
Yes, exactly.
I agreed. Do we have other questions?
Please,
I'm sure. Let me go through. Do you use abbreviation in your variable names?
It depends. No, it depends. The next reflex question you should ask me, it depends on what? It depends on how big project I have. If I have a huge project in which dozens of classes refer to VAT, or if it's a classic term in business world like VAT, I won't write value added text, for Christ's sake. No, VAT, right? But even for my own invented business concepts, if they are used in many places, I would abbreviate, but I would still acknowledge that this is a sign that my application tends towards a monolith. This is a sign that my application grows too big, that I should probably fragment it vertically in subdomains, like domain-driven design style, because collisioning in between names in the different places, right? So it doesn't have a very narrow enough context for me to be fluent, right? If I kept saying PMS for every class that I write in the package, it's a bit strange. So I would avoid that. I would avoid any class names. Right.
Okay, and I think I know. Yeah. So okay, I forgot that one. You mentioned a talk you will be given soon, and they're asking where. Do you have a link to that?
JLove. This is it.
JLove.
Yeah, I should be here, but I'm not sure if they drew me already. No, they didn't. But I'm here. I'm really looking forward for this pictogram. I would like to. Yeah, but
that's cute.
JLove, yeah, super cool. It's completely free, so don't miss that. And there are way better speakers than me here. Okay.
Yeah, lineup is nice.
Yep.
I agree. Okay, and I think that I think I'm through all the questions. Yeah, I think we're done. So thank you very much. You can go to bed now.
No, I won't. You can imagine, I won't go to bed after this excitement, right? I'll
cool down.
More hours. Yeah. Good. Thanks a lot.
Well, pleasure to have you here, and especially because it's the topic I really love. I'm a big fan of all about refactoring. So thanks for being there, and hopefully we'll see each other soon in real life.
Yeah. Yeah. Good. Thank you. Thank you for the
thanks.
Take care. Bye.
Good night.
Good night.
Bye.